What if you could slow down or even reverse the aging process? It sounds almost too good to be true, right? But new research is making us rethink what we thought we knew about growing older. Aging isn't just about wrinkles and gray hair. It's about feeling tired, losing energy, and watching our bodies struggle with things that used to be easy. But what if those symptoms could be addressed at the cellular level? In this video, we'll explore groundbreaking research from scientists like Dr. David Sinclair and Dr. Shinya Yamanaka, who are at the forefront of discovering how molecules like NAD+ and techniques like cellular reprogramming might help keep your cells young and healthy. Stick around to learn how these discoveries could change the way we age and what that means for you. What is NAD+, the molecule that powers life? NAD+ is a small molecule that plays a big role in keeping our bodies running smoothly. It's found in every cell and helps convert the food we eat into energy, which our cells need to function properly. Think of NAD+ as a kind of fuel that powers our cells. Without enough of it, our cells can't produce energy efficiently. NAD+ also helps repair damaged DNA, which is crucial for keeping our cells healthy and functioning well over time. As we get older, the levels of NAD+ in our bodies start to drop. This decline affects how our cells produce energy and fix damaged DNA, leading to symptoms we often associate with aging, like feeling tired, weaker muscles, and even some diseases. When NAD+ levels are low, our cells struggle to keep up with all the tasks they need to perform, which can speed up the aging process. Dr. David Sinclair, a leading researcher in the field of aging, has been studying how boosting NAD+ levels might help slow down or even reverse some of the effects of aging. His research suggests that by restoring NAD+, we might be able to help our cells work better, giving them the energy and support they need to stay healthy as we age. Dr. David Sinclair's groundbreaking research on NAD+ and longevity. Dr. David Sinclair is a professor at Harvard University, where he focuses on understanding how our cells age and what we can do to slow down that process. His research has zeroed in on NAD+ as one of the key players in cellular health. Dr. Sinclair believes that by restoring NAD+ levels, we can help our cells perform better, potentially slowing down the aging process. In his experiments, Dr. Sinclair has used NAD+ boosters like NMN, nicotinamide mononucleotide, and NR, nicotinamide riboside. These compounds are designed to raise NAD+ levels in the body, and his studies have shown some impressive results. For example, in animal models, boosting NAD+ has improved metabolism, increased energy levels, and even extended the lifespan of certain organisms. Early human trials are also promising, showing that NAD+ boosters can enhance energy and reduce some of the signs of aging, such as muscle weakness and fatigue. One of the key ideas in Dr. Sinclair's work is that aging isn't an irreversible process. He suggests that by replenishing NAD+ levels, we might actually be able to turn back some of the clock's effects, keeping cells healthier for longer. He's quoted as saying that aging is a disease, and it's treatable. This idea has opened up a lot of excitement about the possibility of living healthier for longer, not just adding years to life, but also improving the quality of those years. But NAD+ doesn't work alone. One of the reasons it's so important is that it helps activate other crucial proteins in the body that are linked to aging. These proteins, called sirtuins, play a big role in keeping our cells functioning properly and protecting them from damage. The role of sirtuins, the guardians of youth. Sirtuins are a group of proteins that play a crucial role in keeping our cells healthy. They rely on NAD+ to function properly, which is why NAD+ is so important for longevity. These proteins help regulate several biological processes that are essential for maintaining a youthful body, such as how cells respond to stress, how inflammation is controlled, and how metabolism is managed. In short, sirtuins help keep the body's systems running smoothly and protect our cells from damage. One of the main ways sirtuins contribute to longevity is by promoting stress resistance in cells. When cells are exposed to harmful conditions, such as oxidative stress, sirtuins help them recover and continue functioning. They also reduce chronic inflammation, which is a major contributor to age-related diseases. Additionally, sirtuins are involved in regulating metabolism, ensuring that energy is used efficiently. However, as NAD+ levels decline with age, sirtuin activity also drops. This reduction in sirtuin function means cells become less resistant to stress, inflammation levels can increase, and metabolism may slow down, all of which contribute to the aging process. The close relationship between NAD+ and sirtuins makes it clear why boosting NAD+ is so important. By maintaining NAD+ levels, we help ensure that sirtuins can continue to do their job, keeping cells healthier for longer. Now that we've explored how NAD+ and sirtuins work together to protect our cells, let's shift focus to another fascinating area of aging research: Dr. Shinya Yamanaka's work on cellular reprogramming. Dr. Shinya Yamanaka's cellular reprogramming. Dr. Shinya Yamanaka is a scientist who made a groundbreaking discovery that earned him the Nobel Prize. He identified what are now called the Yamanaka factors, specific genes that can turn adult cells back into a more youthful, stem cell-like state. This process, known as cellular reprogramming, allows cells to essentially reset themselves, shedding some of the damage they've accumulated over time. It's a discovery that has huge potential for aging research because it suggests that cells don't have to follow a one-way path toward aging and deterioration. Yamanaka's work ties closely with Dr. Sinclair's research, as both focus on finding ways to rejuvenate cells. While Sinclair's approach involves boosting NAD+ levels to help cells function better as they age, Yamanaka's work aims to actually reverse aging at the cellular level by turning back the biological clock. The idea is that if we can figure out how to safely reprogram cells, it could lead to methods for reversing signs of aging and potentially treating age-related diseases. Although this research is incredibly exciting, it's important to note that it's still in its early stages. Scientists are learning more about how to apply cellular reprogramming safely without causing unintended effects, and much remains to be explored. With these cutting-edge discoveries in mind, the question arises: can aging truly be reversed, or are we simply slowing it down? Let's dive into the broader scientific debate around this question. Can we really reverse aging? The science so far. The progress made in labs like those of Dr. Sinclair and Dr. Yamanaka has been nothing short of remarkable. Studies in animals have shown that boosting NAD+ levels can extend lifespan, improve energy, and enhance cellular health. Similarly, cellular reprogramming has demonstrated the ability to revert aging cells to a more youthful state in lab settings. These breakthroughs have sparked hope that aging might not be an unstoppable force, but something we can slow or even reverse. However, despite these promising results, there are still significant challenges ahead. While animal studies have given researchers important insights, the leap to applying these findings to humans is a large one. Human trials are still in the early stages, and there's much to learn about how safe or effective these treatments might be over the long term. There's also the question of whether the same dramatic effects seen in animals can be replicated in humans, given the complexity of our biology. At this point, the science of aging has advanced to a point where we're closer than ever to understanding how to slow it down. Yet, we have to recognize that there are hurdles to overcome before these discoveries become practical, everyday solutions. The excitement is justified, but so is the caution. Practical ways to boost NAD+ levels today. While scientists continue to uncover new ways to restore NAD+ levels, there are practical steps you can take today to support NAD+ naturally. One of the most effective methods is regular exercise. Physical activity, especially high-intensity workouts, has been shown to boost NAD+ levels in the body. Incorporating movement into your daily routine helps your cells produce more energy and function better. Another way to raise NAD+ is through intermittent fasting. This eating pattern, where you alternate between periods of eating and fasting, can trigger processes in the body that promote NAD+ production. Similarly, focusing on a healthy diet rich in nutrient-dense foods like vegetables, lean proteins, and healthy fats supports cellular health and may help maintain NAD+ levels. In addition to lifestyle changes, NAD plus supplements like NMN and NR are becoming more popular. These supplements work by providing your body with the building blocks it needs to increase NAD+. Both NMN and NR are available in capsule form, and early research shows they might offer benefits for energy, metabolism, and overall well-being. However, it's important to note that these supplements are still being studied, and the long-term effects are not fully understood. That's why it's crucial to consult a healthcare professional before adding any NAD+ boosters to your routine. What's next for NAD+ and anti-aging research? The future of NAD+ and anti-aging research is full of promise, with exciting clinical trials and new therapies pushing the boundaries of what we understand about aging. Scientists are currently exploring innovative treatments, from gene therapies designed to restore NAD+ levels to regenerative medicine that could potentially repair or replace damaged cells. These therapies aim to not only slow aging, but also reverse some of its effects, offering the possibility of healthier, longer lives. Dr. Sinclair and Dr. Yamanaka remain at the forefront of this research. Sinclair continues to investigate how boosting NAD+ can rejuvenate cells, while Yamanaka's work on cellular reprogramming is opening up new possibilities for turning back the biological clock on aging cells. As their studies advance, we're inching closer to real breakthroughs that could transform how we age. However, with these exciting advancements come important questions about ethics and accessibility. How can we ensure that these therapies are available to everyone, not just a select few? And what are the long-term effects of dramatically altering the aging process? These are questions that scientists and society will need to address as the research progresses. Despite these challenges, the outlook is hopeful. The potential for real effective anti-aging treatments is becoming more realistic every day. While we're not quite there yet, the advancements being made today suggest that these treatments could become part of mainstream healthcare in the not-too-distant future. The future of aging and human longevity. We've covered a lot of ground in this video, exploring the powerful potential of NAD+ and cellular reprogramming to slow or even reverse aging. We've seen how NAD+ plays a critical role in keeping our cells healthy and energetic, and how scientists like Dr. Sinclair are working to restore NAD+ levels to extend life and improve overall well-being. We've also touched on Dr. Yamanaka's groundbreaking research, which shows that it may be possible to reset the biological clock on aging cells. While these discoveries are still developing, the progress being made offers real hope. The idea that aging could one day be slowed or even stopped is no longer science fiction. It's a goal that's becoming more tangible every day. Staying informed and taking steps to support your health now will prepare you for the advancements that are on the horizon. The future of aging research looks bright, and as scientists continue to push the limits of what's possible, we may soon find ourselves in a world where aging is no longer something to fear, but something we can control. Until then, the key is to stay engaged, stay hopeful, and take care of your body as science moves forward. If you're interested in learning more about anti-aging, longevity, and the latest health research, be sure to subscribe to the channel for future videos. We'd love to hear your thoughts. Do you think aging can be reversed? Or maybe you have questions about NAD+ and other anti-aging therapies. Share them in the comments below. Thanks for watching, and remember to prioritize your health by staying informed on the latest scientific breakthroughs. Stay curious, stay healthy, and we'll see you in the next video.